So in the last task, you added algebraic fractions with common denominators, and now we're going to see what happens if they're not common denominators. What if the denominators are unlike denominators? And so here, the trick is you must get common denominators before you can add them. You just have to do it. So the easiest way to do it is if you look at example 1a, we're adding 5/6 plus 1/3. So the denominators are a 6 and a 3. Those are not the same number. So we have to get them to be the same number. And the easiest way to do that is to take the first one and multiply it by the second one. When I say 1, take the first fraction, 5/6, and multiply it by the denominator of the second fraction, 3 over itself. And then likewise, take the second fraction and multiply it by the denominator of the first one over itself. So this trick is going to get us common denominators because the first one we have 3 over 3 times 5 over 6, so 3 times 5 is 15, and then 3 times 6 is 18, so we get 18 as the denominator. And the second one we're going to get the same denominator because we're multiplying 3 times 6. So on top 1 times 6 is 6, and then 3 times 6, 18, and voila, common denominators, 18s. So then we can go ahead and add 15 plus 6 is 21 over 18, keep that common denominator. But then we have to remember from task 1 to simplify. So 21 and 18 are both divisible by 3. So I divide those by 3 to get the final answer of 7 over 6. Okay, so these ones take a little more work, but if you just look at the other denominator, multiply it by it, then it's going to work out. So 3 over 6 plus 8 over 10, same thing. I'm going to multiply the first one by 10 over 10, and the second one by 6 over 6. Now there is a faster way to do these, but I'm just showing you the easy way that it's going to work no matter what. So 10 times 3 gives me 30 over 10 times 6, which is 60, plus 8 times 6 is 48 over 10 times 6, 60. Again, common denominators. I add, I get 78 over 60. And again, I got to see what can I divide by. Well, they're both even. If you check, they're both going to be divisible by 4. And so then I'm going to divide by 4. And I get, what do I get? Oh, that's not actually divisible by 4. I get a fraction. So 4 doesn't work. 6 works. Let's try that. So if I divide by 6 on top and on bottom, then I get 78 divided by 6, I get 13. And 60 divided by 6, I get 10. And then 13 is prime, so no more factors. So 13 over 10. Now, so those ones don't have any variables. And so in example 2, we get algebraic fraction, so they have variables. But the nice thing about the way I'm teaching this, I hope, is that it's the same process, even if you have a variable. So again, I've got 5x over 8 plus x over 2. I'm going to multiply by 2 over 2 and 8 over 8. So then I get 2 times 5x, 10x. Don't forget the variable. 2 times 8 is 16, and then plus x times 8 is 8x over 16. Magically, common denominators. Now I can add 10x plus 8x, 18x over 16. And those are even numbers. So I can simplify, divide by 2. And so then I get 9x over 8. Now in B, we have a variable in the denominator, 1 plus 2c over 4c plus 5/6. Doesn't change anything. we still do the exact same thing. So I'm going to multiply the first one by 6 over 6, and the second one by 4c over 4c, including the variable c. And so then I get, not forgetting the distributive property here, 6 times 1 is 6, plus 6 times 2c, 12c, over 6 times 4c, 24c, plus 5 times 4c is 20c, over 6 times 4c is 24c. So the denominators match, including the variable c. Then I can add by combining like terms. So I've got a c term and a c term. So combine those, I get 32c, and then I have the 6, the order doesn't matter, over 24c. And it'd be easy to stop there, but I noticed that all of these numbers are even. So I can divide all of these by 2, and I'm running out of space. But let's see if I can do it over here. So 32c divided by 2 would give me 16c, and then 6 divided by 2 would be 3, over 24c divided by 2 would be 12c. And now they don't have common factors because 3 only has 3 and 1 is a factor, but 16 isn't divisible by 3. So that's the simplified answer. And notice it'd be tempting to cancel the c's because you have 16c over 12c, but since the 3 does not have the variable c, you can't cancel. It has to be common to every term. Okay? Now there's one more in this section, and it looks even more complicated. We've got 3y plus 5 over y minus 3 plus 2/3. And so the first fraction has a y minus 3 in the denominator, not just a number, not just a variable. But it turns out we can do the exact same trick. So I'm going to multiply the first one by 3 over 3. And what do you think I'm going to multiply the second one by? Y minus 3 over y minus 3. Okay? So same process, even though it's a difference, not just a term. And so then, don't forget to distribute. So I got 3 times 3y, 9y, 3 times 5, positive 15, over. Now here, I'm not going to distribute the 3 in the denominator because I want things to be in factored form in the denominator. So then over here, I'm distributing the 2. So 2 times y, 2 times minus 3, over, again, 3 times y minus 3. Notice, that and that are the same. That was the whole purpose of that. So now I can combine the like terms. So I've got a 9y plus a 2y, and so that gives me 11y. And then I've got a plus 15 and a minus 6. So that gives me positive 9 all over 3 times y minus 3. And I do want to check 11 and 9 and see if they have any common factors with the 3. And they don't, because 11 is prime, and so then that is the final answer.